Okay, this is going to be 26 when we are done. What is this word right here in all caps? Review, because this is something that you already have learned, okay? It starts in Algebra 1. You do it some more in geometry. You do it a lot in Algebra 2. So I should not have to go over this, but I'm going to make sure you've all heard it. Nobody can say nobody ever taught me, because at least I've taught you. But you've got to get it figured out and get it figured out quick. So after this lesson and after this assignment, if you still have no idea how to factor, that's a huge problem, okay? You have to be able to do it accurately, efficiently, and a lot, okay? So we're going to start with GCF, greatest common factor. There's a difference between GCF and just CF, between a common factor, right? So in this first one, in number 1, could I factor out a 2? Yes, I could, but that's not my GCF. It's just a common factor. And sometimes you might only need to factor out the 2, and that's fine. But here we're trying to do the greatest common factor. So looking just at the number piece, between 24 and 54, what could I factor out? Okay, I heard 6 and 8. So I know they both divide into 24. Do they both divide into 54? No. Only 6 does. We have to know our multiplication facts here, guys. So 6 can factor out. Then how many y's can I take out? 3. So y cubed. That leaves me with 4y minus what? 9. Okay? Get a flashcard app. Do something. You got to know your multiplication facts. All right, so just because we're trying to factor something out doesn't always mean that it factors out, right? But maybe it does, and we should always try. So when we look at number 2, we have, for the number part, 51 and 17. Can I factor anything out? What are the factors of 17? So what are the factors of 17? 1 and 17. Okay, my question wasn't, is it prime? My question was, what are its factors? Its factors are 1 and 17. And when you're factoring something out like this, the 1 doesn't do anything. But is 51 divisible by 17? Yeah, it is. How many times does it go in there? 3. So I can factor out the 17. And how many a's can I take out? 3. How many b's can I take out? 4. So then that leaves me with 3 times a to the 5th plus b. So you got to try and not just assume that because 51 for sure is divisible by 3 because 5 plus 1 is 6, right? So that's how I know for sure it's not a prime number, and I could try something. All right, so let's talk about a difference of squares. First of all, your perfect squares are 1, 4, 9, 16, 25, 36, 49, and so forth, right? You should know your perfect squares up to 25. Are you okay? Yeah, go ahead. Up to 25, and I don't mean this 25 because that's really 5 squared, but up to 25 squared. I want to remind you that on the AP test, you only get a calculator on half of it. The other half, they're not going to be asking you to do crazy decimals and crazy things, but you may have to take square roots of numbers that you're not familiar with, or you may have to add, subtract, multiply, and divide, and you've got to be able to do that accurately and not spend your time on the arithmetic when you really need to be spending it on the actual material. All right, so the way that difference of squares works looks like this. A squared plus b squared. Oh, no, it doesn't. That's the sum of squares. That makes no sense. A squared minus b squared. Okay, there is no, sum of squares exists, but you can't factor it. You can only factor difference of squares. And when you do this, your rule is very, very simple. It just makes it a plus b times a minus b. This kind of thing comes up quite a lot, so being able to factor it is like super easy and super quick. And all you got to do is take the square root of the first one, square root of the second one, and put them in their parentheses correctly. So when we look at number 3, this is a perfect square and this is a perfect square. So I'm going to have 2 binomials. One of them is plus, one of them is minus. And then I just plug the same things in. What's the square root of 36w squared? 6w. What's the square root of 25? 5. So it's 6w plus 5, 6w minus 5. And it does not matter if the minus or the plus goes first. It doesn't matter at all. Okay? We good? Okay. Are you good? Yeah. Okay. All right. So on number 4, is this a perfect square? Yes. Is this a perfect square? Yes. So what is the square root of 1 over 44? Or I'm sorry, 1 over 144. 1 over 12. Okay. Plus, what is the square root of r to the 6th s to the 4th? R cubed s squared. When you take the square root of variables that have exponents on them, you're just dividing the exponent by 2. So then this will be times 1/12 minus r cubed s squared. Okay. So we could see it like this. We could see it with a bunch of variables and fractions. Really, mostly, you'll have something super simple like x squared minus 49. And there's nothing complicated about that. It's x plus 7 times x minus 7. Right? Okay. Just got to be able to recognize it and get through it. Shouldn't take you longer than a couple seconds. All right, we don't have time to focus on that stuff. All right, now let's look at sum and difference of cubes. We've got, so let's talk about our perfect cubes first. We have 1. What's 2 cubed? 8. What's 3 cubed? 4. 64. 5. 125. You think of having 5 quarters, right? What's 6? 216. Knowing up to those is kind of, at the very least up to 5. Knowing 6 sometimes is helpful, so we're not having to do guess and check type of stuff. Just think about that. All right, so we're going to look at the rules for factoring these together because, like I said, a sum of squares exists, but you can't factor it. You can only factor the difference of squares. But you can factor the sum and difference of cubes, and the patterns are very, very similar. So let's look at what those patterns are. So first of all, if it's a sum of cubes, it looks like this. A cubed plus b cubed. And this one will be a cubed minus b cubed. Okay. In both cases, so that means I have, instead of having perfect squares, I have perfect cubes. In both cases, when you factor them, you will get a binomial and a trinomial. Okay, so we're going to get the terms in there, and then we'll worry about the signs that go with them later. Okay, so to figure out your binomial, you take the cube root of the first term, so the cube root of a cubed is a, and the cube root of the second term, cube root of b cubed, is b. That works exactly the same for both of them. Okay. Then the way you fill in your trinomial is you take what's in your binomial, you take this first term, in this case it's a, and you square it. That's a squared. That's your first term. Works in both of them. Then to get your middle term, you multiply these two together, so this will be a times b. And then to get the last term of the trinomial, you square the second term in your binomial, and you get b squared. Do you see how this process right here, it's identical? Whether you're doing sum or difference of cubes, it is literally exactly the same. We good so far? Okay, so to figure out the signs, we use SOAP. Okay, SOAP is your savior for sum and difference of cubes. This stands for same, opposite, always, positive. Same, opposite, always positive. This is what this means. This is the sum of cubes right here that we are factoring. So this sign is plus, so it's the same. It's the opposite. It's always positive. This one is the difference, so the sign is the same. Opposite, always positive. So if you can remember the pattern to get the terms in there, and you remember SOAP, you can get the signs in there. And do whichever one first makes more sense to you. Okay, we good on that? All right, let's look at how this works, these actual equations here. So I have h cubed plus 125. Those are both perfect cubes. So I'm going to set up my little parentheses here. Cube root of h cubed is h. Cube root of 125 is what? 5. Okay, so we all understand how we get those two? Then we square h, that's h squared, it goes right here. Then we multiply 5 times h, that goes right there. Then we square 5, that's 25, that goes right there. Then we get our signs in there. This was a positive sign, so this is the same, opposite, always positive. Okay, make sense? Just be consistent with your pattern. So let's look at 8. Again, 2 perfect cubes, so binomial, trinomial. What is the cube root of 8f cubed? 2f. What is the cube root of 27? 3. Okay, so then what is 2f squared? 4f squared. Good, you got to square it all. Then I multiply them together and get 6f. Then I square 3 and get 9. Get your signs in there. Same, opposite, always positive. Right. What questions do you have? We all good? Okay, so let's look at the difference. Now this one I'm gonna do it in a little bit of a different order just to show you can do whatever makes the most sense to you. I don't care either way. But so I've got 2 perfect cubes here. I still have a binomial and a trinomial. So this time, instead of getting my terms in there first, I'm going to put my signs in there first. And you can decide which way you like better. Like I said, it doesn't really matter. This is minus, so this is going to be the same, opposite, always positive. I usually do it the other way, because when I do it this way, I don't always leave myself enough space to write stuff. But like I said, I'm just going to show you different ways to do this. So I take the cube root of x cubed, and that is x. Anybody know what the cube root of 343 is? 7. Okay, so I heard 7 and 9 today. Those were the things I heard, which are reasonable guesses. So let's just take a little side trip here and talk about that for a minute. If you're wondering, without actually multiplying everything out, because sometimes y'all do too much to figure things out and you want to kind of do things in a little bit more efficient way. So let's say, like, I don't know if it's 8, I don't know if it's 7, I don't know if it's 9, but let's say that we think it's 9. So we know that 9 times 9 is 81, right? And now without actually multiplying 81 times 9, if I did multiply 81 times 9, what would that last term be? 9. And that one is a 3, not a 9, so I don't think it's 9. You with me? And who cares what it actually is? Like, you're just trying to see. And that's the other thing, is if you practice these at all, you should at least recognize 343 as a perfect cube. Even if you don't remember which one it is, you know it's in that list, so you know you're not wasting your time. Does that make sense to you too? And that makes sense. Yeah, and so knowing it's a perfect cube, it's really close to the 6, like she said, not enough for 8. So knowing those kind of things, you can narrow it down. So then we know that 7 times 7 is 49, right? And then if without multiplying the whole thing, 7 times 9 is 63, so it ends in a 3, so I'm pretty confident it's 7, right? So it's just kind of some reasoning without literally doing all the crazy scratch work, because it doesn't really matter. All right, so this is 7. So then that makes this x squared plus 7x plus 49. Right? We okay with that? All right. So number 12, binomial, trinomial. Go ahead and get your signs in there. What's the cube root of 125? 5. Oh, here's the other thing I wanted to say. On ones like this, don't flip it around so your variables first and make it negative 8b cubed plus 125. You're just making your life harder. Just leave it like it is, okay? Then what's the cube root of 8b cubed? 2b. Okay, you try, or you don't try, do. Fill in that trinomial right there. Y'all agree with that? Okay. Any questions? I know I'm going quickly, but this is a review, so I want to make sure I get through all these different kinds. If you got to slow it down, you can go back and practice slower on your own, but none of this is being taught from scratch. Okay, let's look at trinomials. So for these first 2 trinomials, A is 1, and that's great, because when A is 1, I can jump directly to having 2 parentheses. Then before I start thinking numbers, I'm going to set it up and think about some other things first. This is m squared, so this is m and this is m. This is a negative 30, which tells me that the signs inside the parentheses are opposite. That's important because I now need two numbers that multiply to give me 30 and combine to give me 13. Is 3 times 10 30? Yes, and 3 plus 10 is 13, right? Are those my numbers? No, because they're going to end up being subtracted, right? So if you're thinking about the signs before you worry about numbers, you won't fall into that trap. You with me? Yes, ma'am. Okay, what's the positive number? 2, and the negative is 15, absolutely. Okay, we good with that? So this will become easier if you think through those things. You won't fall into those traps because a very common wrong answer for this one would have a 3 and a 10 in it. All right, so then on this one, this is quartic. It's not quadratic, but it's the exact same process. So the square root of x to the 4th is x squared. Put an x squared here and x squared here. That's a negative 20, which means my signs are opposite. Okay? Now I need two numbers that multiply to give me negative 20 and subtract to give me negative, or combine to give me negative 1. What's my positive number? 4. And my negative number? 5. Can I factor this one anymore? No. This is a sum of squares that exists, but I can't factor it, right? And this is a difference, but it's not a difference of squares, so I can't factor anymore, and I'm done right here. Okay, we good? All right, let's look at 17. Now, 17 and 18, these have, A is not 1. Now, you could have learned how to factor these multiple different ways. But over the past few years, it's very consistently been that the majority of students have come having learned grouping, which is what we're going to do. If you live and die by the box method, I would try and migrate to something else because you ain't got time to draw boxes, okay? So this is going to be 2. I'm going to take 2 times negative 7, which is negative 14. So I need two numbers that multiply to give me negative 14, combine to give me negative 13. What would those be? So it's negative 14 and positive 1, right? Because I got to multiply to give me this. And okay, so I get 2d squared minus 14d plus d minus 7. Right? So then I've got grouping here. So I'm going to group these two and group these two. So I'm going to factor out here a 2d, which leaves me with d minus 7. Out of these two, I can't factor anything out, but like with the GCF, we didn't factor a 1 out, but here we have to factor a 1 out or this doesn't work. So plus 1 leaves me with d minus 7. So then my answer is 2d plus 1 times d minus 7. Okay? If you have a different way to do it and it's accurate and you can get the right answer, because like I said, there's lots of different ways to teach it. In my opinion, this one is the best because it works with other things, not just trinomials, and that's important. Okay? All right, so let's look at 18. I'm going to have to do 4 times 9. What's that? 36. So now I need two numbers that multiply to give me 36 and combine to give me a negative 13. Negative 4 and negative 9. Does it make sense that they're both negative? Yes, because this is positive, which means the signs have to be the same. This is negative, which means that they're both negative. So this gives me 4q to the 4th minus 4, let's see, no, let's do minus, what was it? 4, 9, minus 9q squared minus 4q squared plus 9. And we could have put the 4 first. I flipped it on purpose so I could talk about something. But so now that I'm here, I'm going to factor. I'm going to group them. And then I can factor out here. I can't factor out a number, but I can factor out a q squared, right? Okay. So I get q squared times 4q squared minus what? 9. Okay. Then out of these two, I can't factor anything out, but if this is negative and you're going to factor something out, you have to factor out the negative 1 to make it make sense. 4q squared minus 9. And the things you have in parentheses should always match each other, right? So then that leaves me with q squared minus 1 times 4q squared minus 9. Can I factor this anymore? Yes. Can I factor both of them more? Yes. Okay, so then this gives me q plus 1 times q minus 1 times 2q plus 3 times 2q minus 3. And then I am done. And if you think I'm up here like doing magic, I'm not, and that should be very concerning, okay? So this should all be like, yes, yes, I might need to knock off some cobwebs, but I can totally do this, and I'm not going to freak out, and everything's going to be okay, right? We good? All right, so factoring by grouping. So this is actually easier than this, even though it has 4 terms and that has 3, because with the trinomial, we had to split it into 4 to do grouping. Here, we already have it into 4, so now I can just group them and move on. Group this, group this. So out of these two, I can factor out an h squared. Leaves me with 2h minus 3. Out of this, I can factor out a 3, which leaves me with 2h minus 3. If my parentheses don't match, that's a problem. And then that gives me h squared plus 3 times 2h minus 3. Can I factor this anymore? No, I'm done factoring. Now on 22 on my board, the z's look like equal signs, which make this look really weird, but I think they actually look like z's on your paper. Things just don't always look good up here. Okay, these just look like weird, looks like a really strange thing that's not even an equation. But I can group these, right? And so out of these two, I can factor out a z squared. That leaves me with z plus 7. Out of these two, I can factor out a negative 5, which leaves me with z plus 7. So then I get z squared minus 5 times z plus 7. Can I factor any more? Nope, I'm done. Okay, so this next set says to solve. So we know that we can factor things to solve. We've been factoring. How come we haven't been solving? Anybody know? It didn't ask us to, number one. And second of all, because sometimes I hear, well, I don't know when I'm supposed to keep going and find 0 and when I'm not. Well, everything we've done so far has been an expression. It's not even an equation. If you don't have an equation, you can't solve it. Make sense? You have to have an equal sign to be able to solve it. And just because you have an equal sign doesn't necessarily mean you want to solve it, but these directions say solve, so that's what we're going to do. Okay? All right, so let's look at number 25. And if I'm going to solve something by factoring, the first thing I want to do 99% of the time is set it equal to 0. This one is set equal to 0, so that's nice. And then I want to look at a GCF. What would my GCF be here? 5n. Okay, so that leaves me with n to the 4th minus what? 16. Thank you. And that equals 0. Do not lose your equals 0. You cannot have random chicken scratch everywhere. Your process has to flow. And when you lose your equal signs and your zeros, and you really just start saying things, you think you're doing stuff, but what you're saying is all 100% illegal, so keep it clean. Can I factor this some more? Yes. So I'm going to have 5n times n squared plus 4 times n squared minus 4 equals 0. Can I factor more again? Yes. Can I factor this one? No. So I'm going to rewrite 5n times n squared plus 4. Then that's another difference of squares. So n plus 2 times n minus 2 equals 0. Now that it is completely factored, I can use my zero product property. And when I do that, I cannot forget about this guy right here. He's super important. When I set 5n equal to 0, what does n equal? 0. So my n's, we're going to have 0. Then I'm going to set this one equal to 0. So n squared plus 4 equals 0. So n squared equals negative 4. So what does n equal? Very close. You're going to end up in math jail. Very close. I'm going to send y'all all to math jail. You can all hang out. I hope you know each other well. The 2i part is right, but you're missing something else. Plus or minus 2i. If you introduce a square root, you have to put plus or minus. So then I have plus or minus 2i, and then I'm not going to bother writing these out. If I set this equal to 0, I get a negative 2. If I set that equal to 0, I get a 2, right? So this is a 5th degree polynomial. I have 5 zeros. In this case, 3 of them are real, 2 of them are imaginary, but together I get 5, right? How many times does this function cross the x-axis? 3, because I have 3 real zeros, right? The imaginaries aren't actually intercepts because they're not actually on there the way we think about them. Okay, we good on that? That make sense? All right, good deal. Let's look at 26. So what do I need to do first on 26? Okay, move the 4. Could I move everything else to the right instead? Yes, either way, it doesn't matter, right? But 4 makes it a little bit easier. So negative 6k squared minus 14k equals, no, it doesn't because we're subtracting, sorry, minus 4 equals 0. Now, if I was doing this one on my own, that's exactly what I would have done. I would have moved everything over to the right because then it's positive because I need my k squared to be positive, but it's fine. Like, it doesn't matter either way. We'll get the same answer. Do I have a GCF? Yes. And it is a negative, what, 2. So that leaves me with 3k squared plus 7k plus 2 equals 0. By moving everything to the right, keeps me from factoring out that negative and possibly messing up on a sign somewhere. Just saying. All right, so then I'm going to have to factor by grouping. So 3 times 2 is 6. 2 numbers that multiply to give me 6 combine to give me 7. 6 and 1. So negative 2 times 3k squared plus 6x. No, that's a k, sorry. 6k plus k plus 2, close my parentheses, equals 0. You cannot drop that negative 2 off. He is still a very important part of that function. Don't lose him anywhere. All right? So now, because I already have parentheses and stuff, I'm going to use some brackets. So I'm going to do negative 2. I'm going to open my brackets. Out of these 2, I'm going to factor out a 3k. That leaves me with k plus 2. Out of these 2, I'm going to factor out a 1. So that leaves me with k plus 2. And all of that is equal to 0. So then I have negative 2 times 3k plus 1 times k plus 2 equals 0. So now when I use my 0 product property, does this affect my answers at all? No, it doesn't, but you still can't drop him off because if we were going to go and graph this thing, he's a very important part of what actually gets graphed. You with me? So you cannot get sloppy just because you're factoring and you know it doesn't affect your 0. All right, so then when I use my 0 product property, this 3k plus 1, what does that give me? Negative 1/3, and this gives me negative 2. Any questions at this point? All right. And let's look at number 28. So again, I want my n squared to be positive. I could move everything over to the left, but I don't want to have to worry about negatives, so we're going to move it to the right, just to be different than the other one. That's going to give me 6n squared plus 8n. So do I have a GCF? Yes, it is 2n, right? Leaves me with 3n plus 4. So n is equal to, what's this first one give me? 0. And then this gives me negative. If you need to write it down, you absolutely can. I'm not saying you can't. I'm saying you don't have to, and it depends on where you are in your learning and your comfort. You don't want to mess things up, totally fine. But then you can solve it, but you're going to get negative 4/3. We good? What questions we got? All right, let's look at 29. So the first thing I need to do is set this equal to 0. Should I move it to the left or the right? Left. This way, right? Okay. So we're going to get, so when I subtract, I'm going to get 2x squared minus 8x minus 42 equals 0. Now, if I don't factor out the GCF, I can still factor this and get the right answers, but my numbers are going to be way bigger, right? Because I have to multiply 2 times 42. Like, it's possible, but you're way better if you actually factor it out. So I factor out my 2, going to give me x squared minus 4x minus 21. Set that equal to 0. Now a is 1. That's really nice. That makes this a whole lot easier. So I can set my 2 parentheses up. Set that equal to 0. I know this is x and x. This is negative right here, so the signs are opposite. What's my positive number? 3, and my negative number is 7. So my x values are -3 and 7. It's very important that you are factoring, and the end right here, if I multiply all of this back together, I get what I started with. All right? If not, you're dropping things off, and that's going to cause you issues when other things we do that's not just solving the quadratic. Okay? We good? All right, let's go ahead and do this last one since we have time. Just get them all done. So I can, let's see. Mine looks funny. Where is the equal sign? Does it have one? Oh, it doesn't even have one. So I wonder if, so let's make it equal to 0, and then we'll solve. Hopefully it's factorable. Hopefully I didn't totally mess this up. I'm pretty sure it is. Yeah. It is. So do I have a GCF? Yes. So this is 6 times z to the 4th minus 5z squared plus 4, right? Equals 0. So this is nice. A is 1 again, right? So I get 6 times, and then I'm going to have 2 sets of parentheses here. This, since this is z to the 4th, these would both be z squared. This is positive, so the signs are the same. This is negative, so they're both negative. 2 numbers that multiply to give me +4 combine to give me -5. -4 and -1. Good. Can I factor this more? Yes. Both of them? Yes. So I'm going to have 6 times z plus 2 times z minus 2 times z plus 1 times z minus 1 equals 0. All right, we good? So that's completely factored, right? Now when I write my answers, I can see that this is going to give me a -2 and a +2, so I can put plus or minus 2, and a -1 and a +1, so I can put plus or minus 1. If you list all 4 of them out, that's fine too, but that's also okay. That's right, absolutely. We good? Any questions? On that Delta Math, if all you do is photo math everything, congratulations, you got 100 on a homework assignment that doesn't even affect your grade. Okay, so you're not doing anything, you're not getting anywhere with it. Big whoop, okay? So you have to get this figured out. One of the reasons I put this in Delta Math is because it has great videos, great explanations. If you know how to do this stuff, you'll knock it out quick, no big deal. If you're struggling with it, take the time to watch those videos. But after this, you have got to, I'm not reteaching factoring every time it comes up. That is absolutely not happening, okay?